A few months ago, I was going back and forth in email exchanges with a subscriber who is trying to get the free mix tweaked to the output that he was looking for and color he was looking for. And he asked me a follow up question, which I never really responded back to. And initially, it was intentional. And then over time, I just kind of forgot about the email. Sorry about that. But the question was, whenever we decided upon our PARTAY color scheme, was there logic behind the colors that we landed on, or was it just a shot in the dark? And the answer is yes to both. A Daystar was our first creation, and it was based upon a manufactured screen color. Oddly enough, we jumped from Daystar to starting to make a black screen, our first black creation, which was Sirius. Now it's there that we learned a lot of things that have now put us in a different position than where we started, where it would have been just kind of a shot in the dark from Daystar and where to go next. Now, I'm going to try to keep this to summarize bullet points, but essentially, whenever we were working on Sirius, we were doing some reflectivity tests and, other little side tests, but nothing that really helped advance us. It was only whenever we, kind of like in The Martian, you decide to science something out, right? We started keeping journals and started watching the variances. And essentially what that led us to, and what we discovered accidentally, actually, whenever we were working through it, was that even though you had deltas in transmission in your darker screens that were more shallow than the deltas in transmission for your lighter screen, Daystar, what we found is that as we started to create other screen types, just let's say Vega, right, in its test phase, what we started to discover is that those deltas, while they weren't the same, they were much more shallow on the black end than they were on the lighter end. But what we discovered is that there was commonalities in the deltas there. What that means, or meant for us, is that we actually had a way to calibrate screen color and find sweet spots. Sweet spots meaning those areas where you can go up in color, and here we refer to them as color bumps, but you could go up in color and lose less transmission, right? As you got darker, if you go from, say, shade A to shade B, the deltas were smaller, but at the same time, the transmission was much smaller too. So when you started to put it all together in a data format, and you started to look at the trending of what was happening, what you saw, there were commonalities, and there would be these sweet spots where you would be able to create a screen color and really have more of an improvement in an area and less loss in an area that you don't want to lose, like brightness. So it really helped us to put method to the badness. If we'd have stayed the path of just trying to go from, say, Daystar to find out what our next screen was, it would have been just trial and error. And we were able to actually bring that down to something where we could predict what the color was going to do. It was just a matter of finding that right tone, getting into that right tone. And then obviously gain plays a big part in that. And you'll notice that all of our screens except for our black screens are generally around the same gain. And another thing to be mindful of is that all of PARTAY screens are made from one color. Okay, it's just a matter of concentration. And so we've been able to essentially, in a bullet point, industrialize the manufacturing process for these. So while we haven't industrialized it from a tooling perspective, we've industrialized it from a predictive analysis of what the screen's going to do, both from from a reflectivity standpoint, from a transmission standpoint, from a diffusion standpoint, and it's really about balancing those three things, right? You've got absorption in there, which is going to be caused to some degree as a part of your diffusion, but overall, it helps us to balance those metrics out so that whenever we put a screen out, we know exactly how it would perform. Now, I say exactly, and I've stated this before, because we're doing this manually, the QA process is not going to be as robust as, say, in a manufacturing plant where you have everything dialed in, from 1 to 1 to 1 to 1 to 1. We're dialed in, but there are still small manual variances that come in. In other words, you may buy Vega, somebody else may buy Vega, and if you were to look at them side by side, they're going to be very similar, probably to the point that you can't notice it, but in some cases you may notice a slight difference between them. And that's just because we're mixing this stuff manually. You may end up with, a small fraction more of this or a small fraction less of that than you would in from canister to canister to canister. That's just being honest, right? But the amounts are really nominal at this point, and we don't use scoops. Can't use scoops. Why? And this is something people don't really talk about, but when you use scoops, not all the paint comes out of the scoop, right? Right? You see people using scoops and they do the paint. Well, it's the same thing with our stuff. So not everything comes out of the scoop, and you would have to scoop it with your finger and try to make sure that you get the exact amount in there. So we use other things to measure out our additives. But it's manual, and there's going to be slight variations, but it should be so slight that it's nominal. In other words, nominal meaning you would not really pick it up. It would not make any change to overall how you perceive the screen. So started in method, moved to madness, and then evolved back to methodology. So now we're able to accurately predict, and you can see. Well, you may not notice as much, but when you're looking across the table here, we've got a white panel to the left, then that's Daystar, then Vega Plus, then Polaris, and then I've actually got the two blacks reversed. The one on the end is Sirius A, and the really black one there is Sirius B. But the three Vegas, I say the three Vegas, it's really Vega Plus, and Polaris. Those three are more like a cluster. Especially Vega and Vega Plus are kind of two sides to one coin. One is going to focus just a little more on brightness. The other focus just a little more on black level enhancement. And the drop in your brightness going to Vega Plus is very minimal, but the amount of black contrast enhancement that you get is pretty significant, considering that the two are relatively close in color. Well, Vega Plus is definitely darker, but they're very close in color by comparison to the other screens, which are going to be shades difference, many shades difference, as opposed to Vega and Vega Plus. So we've got a number of sweet spots in between those that we could roll out products, but the reality here is we're trying to bring it in at something that would satisfy pretty much every appetite without having to carry 10, 12 different screens. And that can get a little on the difficult side. So basically we've got them bucketed into Daystar, which is going to be your dedicated theater kind of space, a lower light environment, really, under 60 lux, probably optimal around 40 to 45 lux, where your Vega Plus is going to stand up in much more light. And then Polaris is going to stand up in much more light. It's not going to be as bright as Vega or Vega Plus, but it's going to carry more, contrast enhancement in the sense of black levels. And we'll get into the black stuff later on. I've got a lot to talk about when it comes to Sirius A and Sirius B, but right now we're focusing on getting our grays out there and make sure that people understand how they work, how they operate. So next up, we're going to do a little more deep dive into ALR and how these screens work. We'll be answering what they do, what they don't do. And if you guys have any questions relative to color or anything like that, we'll be happy to answer any of those questions for you. I think I'm also going to do a quick series on lighting, and we'll talk about lighting environments and all the different aspects, because lighting environment, you hear folks say a lot of times, well lit. Well lit's not a measurement. Okay, well lit doesn't tell you anything. So we're going to start to break down lux count and what you can expect at various lux counts. All right, so with that, I'm going to leave you guys. You guys take care, and we will see you soon. Oh, last thing, as of last time I checked, now this is Tuesday morning. Last time I checked, I think we had 6 or 7 sample packs left. So if you haven't gotten one and you're looking for one, this is the opportunity. Otherwise, like I said, I don't think we're going to carry them again until probably late summer, early fall. All right, you guys take care, and we'll talk to you soon.